this probably looks a little familiar. Eric mentioned it earlier. This is a pre-activity to lesson number 5. The point is not to already have this knowledge. The lesson will teach you what the explanation is. So I want you to just have a discussion about some ideas of what you think it might be related to, what you think it's not related to. Maybe just jot down a couple of notes and we'll just have a conversation about it. By the end of lesson 5, you will have a full explanation for why this occurs. The change of state lesson starts by looking at a glass of cold water and asking, why does condensation gather on the outside?
Water, when it boils, goes from a liquid state to a vapor state, to a gas state, because of heat. Reverse that process by chilling it with ice inside the glass.
Even in the wintertime, there's humidity in the air.
How long will we be leaving the glass of water outside? That would be a key piece, because if you're leaving outside overnight, you're not going to glass of water.
The glass is cooling the water vapor around the air, so it's liquid.
The molecules slow down, they can condense and collect on the side of the glass.
Tried in this lesson set to really tie science concepts to real life phenomena. It was very important for me to give students a way to connect the often abstract quality of science to things that they see, they recognize, and at the end they're able to explain that using the content that we learned. Okay, we're gonna launch into lesson 5. So just to remind you, we just talked about physical properties and physical change, and now we're gonna talk about a physical change of state. In lesson number 5, we start to talk about a specific physical change, which is a change in state, the moving between solid, liquid, and gas. It starts out by just trying to describe to an alien what a solid is and what a liquid is and what a gas is, just using everyday language. Liquid, gas actually also flows, and both liquid and gas are considered fluids because they flow and you can move them around easily. Then we talk about how do we make a change between those 3 states. If you have a solid of ice, how could you make it liquid? So moving between a solid and a liquid, so if you have some ice, which is made of H2O molecules as ice, and you melt that ice to form liquid water, the H2O molecules are exactly the same molecules there. The molecules haven't changed. It hasn't changed identity at all. It has just changed form. So the question is, how do you change between solid, liquid, and gas?
Add energy.
You add energy, okay? So this is a big point of this lesson, is that heat changes the state of matter. When we say change the state, we're saying it's going to change between solid, liquid, and gas. Everybody is able to identify that it's heat. And the question is, how does heat do this? How does heat cause a change of state? So we did a demonstration where we took 2 glasses of water, one very hot water and one very cold water, and we set them down and allow them to come so they're both very still. So there's no visual motion within the glass of the water. And then we put a drop of food coloring into both glasses at the exact same time.
Oh, the cold, it goes slow and straight.
Oh, the cold, it sinks to the bottom.
It expands fast.
The hot is expanding faster.
Sugar and water.
And what you observe very quickly over the course of 1 minute is that the food coloring in the hot water disperses, spreads out, will color the entire glass of water a color, whereas the food coloring in the cold water kind of hangs together in a stringy central mass and does not disperse as quickly. And so we talk about why that occurs. So why don't you describe to me what happened, what was the difference between the hot water and the cold water?
One lingered, one dispersed.
One lingered and one dispersed, right. So which one?
Cold one lingered.
And how would you describe what happened in the hot water? It expanded, it spread out. Yeah. So why do you think that happened in the hot water? Yeah.
The hot water is moving, it's moving faster than the cold water. So when you put the food coloring in, it kind of gets, like wind, like papers in wind, or, it gets mixed in with the movement. So that's how it gets mixed in. While the cold water, it's slower moving, so that when you drop the food coloring in, it kind of just, since it's so slow, and I guess the dye is moving faster than, or moving slower than, it just goes, if it's faster, it's heavier, it goes straight down.
What she's saying is that there's some relationship between heat and motion. And now I'm going to make a distinction here because we were very careful that our liquid wasn't sloshing around. That's not the kind of motion we're talking about, right? The water wasn't moving around on the glass because we put both glasses down and the water was very still. But she's saying that there's more motion inherent in a hot glass of water than a cold glass of water. We're coming back to our definition that matter has mass and volume and is made up of atoms or molecules, and that those atoms can have motion even if we don't see them moving. So we're saying in something hot, the particles move faster. This is a core takeaway of this lesson, is that heat makes particles move faster. And so in a hot glass of water, those particles of the water are moving really, really quickly, and they deliver and disperse the food coloring very quickly. Whereas in the cold water, the particles are still moving, but not very quickly. So they don't disperse the food coloring as quickly as in the hot water.
Are molecules always moving, no matter what? I mean, so like in sand, even though sand, it doesn't look like it's in motion, are they always moving?
Yes, they are. So molecules are always absolutely in motion at all times, even in solids. They're vibrating just a little bit. Molecules are always vibrating slightly. We then used a really great online interactive tool that shows how when you add heat, particles of a substance move faster, 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 and spread out. Get up there, and you can watch up here. Here's the temperature, and you can watch the temperature go up. It's going 45, 46, 47, 48. Okay, what's the heat doing?
Separating them.
Separating them.
Making them move faster.
And they're also bumping into each other.
Yeah. End the lesson by talking about a melting point and boiling point, which is a physical property of matter that doesn't change. And the physical change is the change of state between solid, liquid, and gas. There's a certain temperature where water turns to liquid. If you have ice, it turns to liquid. So that temperature, anybody know what that temperature is? When does ice melt into?
0 degrees Celsius.
0 degrees Celsius, or, we have a couple different scales, right? This is a physical property of matter. The melting point and the boiling point never change. If you have ice and you want to melt it, it's always going to melt at the same temperature. And gas to liquid, that's condensation. And then what are we missing? Solid to liquid? Melting. You can go directly from a solid to a gas. And the place that you might see this is if you have ice cubes in your freezer, and you notice if you leave the ice cubes in there for a really, really long time, what happens to them? They shrink, right? They get like a little bit smaller. And what's happening is that some of the particles in the ice are actually gaining enough heat so that they can fly up and go into the gas state right away, skipping the liquid state. The term for this is called sublimation. I think that having those concrete, recognizable things gives students something to remember. They remember that better, and they can tie it to something real that they see. It's not, this science information doesn't just live in like a textbook. We can actually use it to explain things around us every day.